Hi everyone, in this video we are going to discuss about probability, the subtopic of probability of an event. But before proceeding, I would like to remind you, make sure you subscribe on my YouTube channel, what we call Sanfaume Online, in order to get more tutorial videos of mathematics. You are welcome. Okay, suppose you have a question like this one. You need to find probability of head to appear first when the fair cone is tossed once. So assume you toss a cone, and when you toss it, we expect all two things, either the head to appear first or the tail to appear first. That means the set of a possible outcome, which is presented by S, will consist only two elements, which is either head or what we call a tail here. Okay, from this set of sample space, you can find the number of sample space. Number of sample space, this means the number of elements found on my set of sample space. If you are smart enough here, you will observe only two elements, which is the first one is head and the second one is tail, as you see here. The first one, the second one. That means number of sample space here is equal to 2. But our event is head to appear first. So always event is obtained from the set of sample space. From the set of sample space, I will find my event, which is head. It is only one here. So it is only one head. That means my event, it consists only one element. That's why number of event here, it's supposed to be equals to 1, because on a set of event, I have only one element here. Okay, now let us proceed. We need to find the probability of an event. We know that the probability of an event can be calculated by taking the formula that probability of an event equals to number of events divided by number of sample, something like this. Okay, but number of events is equal to 1, and also number of sample is equal to 2. That means probability of an event now will be equals to 1 over 2, which is a half. Okay, so general, you have to understand the formula. In order to find the probability of an event, always we must take number of events divided by number of sample. This one is a general formula for finding the probability of an event. So you have to understand this formula is applicable in many questions. So make sure you understand it. Okay, let us proceed with the next question. For this question now, we need to find probability of getting even number when a die is tossed. So when you toss a die, you expect the appearing of a number, but we know that die consists an integers from 1 up to 6. That's why the set of sample spaces will be an integers from 1 up to 6. 1, 2, 3, 4, 5, 6. This is because we know that die always consists an integers from 1 up to 6. That's why the set of sample space must be an integers from 1 up to 6. Okay, but what is our event here? Our event here is to get even number. So our event is even number. Now we're supposed to find the even number from our set of sample space. From the set of sample space, the even number here will be equals to this one. 2 is even number, 4 is even, and this 6 is even. So set of event will consist this 2, 4, and a 6 itself, something like this. Okay, but also do not forget to write the number of sample space and the number of event. Okay, let us count the number of sample space. You have to count it. This one is a set of sample space. From this set of sample space, you have to count the number of elements. 1, 2, 3, 4, 5, 6. That's why the number of sample space is equal to 6. And also, how about the event? You have to find the number of events. From this set of events, this one is supposed to find how many elements are there. Here we have only 1, 2, 3. That's why number of events is equal to 3. Then from there, you have to refer the formula. Probability of an event equals to number of events divided by number of sample. Then from there, probability of an event will be equals to number of events, which is 3, divided by number of sample, which is 6. When you simplify, this one will be equal to 1 over 2. That's why probability of an event here will be equals to a half. I'm done for it. Okay, let us move on. Suppose we have another question here. You need to find the probability of getting an integers less than 7 when a die is tossed once. Okay, now assume you have a certain die and you toss it once. What do you expect? You will expect the appearing of an integers from 1 up to 6 because die consists integers from 1 up to 6. So your possible outcome, which is a set of sample space, will be an integer from 1 up to 6. 2, 3, 4, 5, 6. This one will be the possible outcome, which is what we call the set of sample space. Okay, but our event here is an integers which is less than 7. Before writing the set of event, I can write the number of sample space here. Let us count number of sample space. So number of sample space is a number of an element found on a set of sample space. We have to count how many elements we have. 1, 2, 3, 4, 5, 6. That's why number of sample space here equals to 6. But our event, as I said before, the event here is an even number which found on my set of sample space. Oh, no. Our event here is integers which is less than 7. Integers which is less than 7. Okay, you have to check which one will be the integers which is less than 7 from my set of sample space. This one is less than 7. This one less than 7. These three also less than 7. All of these are less than 7. So my set of an event will be the numbers from 1, 2, 3, 4, 5, 6. This one will be the set of an event. From this set of an event, what is number of event? You have to count it. How many elements on the set of an event? This is my set of event. My element are this one. When you count one, this one will be equals to 6. So number of event equals to 6. Okay, now I can find the probability of an event by taking number of event divided by number of sample, which will be equals to 6 divided by 6. From there, I'll find the probability of an event equals to 1. Something like this one. Probability of an event equals to 1. Okay, you have to note something. Probability of an event always it's supposed to be less or equal to 1. And also you have to note that when probability of an event is equal to 1, that means event is completely must occur. But when probability of an event is equal to 0, that means event does not exist. Okay, let us check the other question here. Okay, from this question now, we need to find probability. We need to find probability of getting even number from the list of this number. Okay, we need to find probability of even number from list of this number. Now this number will be my set of sample space. So here, set of sample space will consist the following element, which is 3, 5, 7, 9, and 11. This one is a set of sample space. Okay, what is the number of set? Number of sample space. The number of sample space here, I'm supposed to count how many? 1, 2, 3, 4, 5. So number of sample space here is equal to 5. Okay, now my event. What is the set of event? To find set of event, you're supposed to refer from the question. What you're supposed to find? I need to find the probability of getting even number. That's why my event is even number. So you have to look the even number from the set of sample space. How many even number are there? If there's no even number, then your set of event will be empty set. As you see here, there is no any one even number from this list of number. That's why my set of event will be equal to empty set. That means number of event will be equals to 0 because there's no any element on the set of event here. My set of event is empty set. Okay, so now I have number of event here and also I have number of sample. Okay, you have to refer from the formula. Probability of an event is equal to number of event divided by number of sample. From there, you will find this probability of an event will be equals to number of event 0 divided by number of sample. Number of sample is equal to 5. But when you take 0 divided by 5, this one will be equal to 0. Okay, therefore, probability of an event will be equals to 0. And since probability is equal to 0, that means our event does not exist. As I said before, when you find the probability of an event is equal to 0, this means event does not exist. And also, when you find the probability of an event is equal to 1, that means event is completely must occur, right? Okay, so for this case, probability is equal to 0. That means event does not exist. And this one is correct because you can't find even number from this set of number. That's why the event of finding the even number from this set of number is not exist. That event doesn't exist at all. That's why at the end of the day, we find that the probability of event here is equal to 0. Okay, let me shift. Here we have a worked example. Okay, let us check the first question. From the first question, it says that a drawing pin was tossed 1,000 times. You need to the number of tosses where the pin fell flat, that was this one. You need to calculate the probability that when such pin is tossed, it will be the flat. Okay, the number of trials here will be the number of sample space. So he tries 1,000 times. That means this one will be the number of sample. Okay, now I can say the number of sample space. This one equals to thousands, like this one. But also our event is to find that the pin fell flat. But according to this question, say that this times pin will fall flat according to this instruction, where the pin fell flat, that was this one. So this times pin will fall flat, and we need to calculate the probability of such a pin to fall flat. That's why our event is falling flat for a pin. That means number of event which is falling flat of a pin is equal to 563, something like this. Okay, now from there you have to proceed from the formula. Probability of an event equals to number of events, this one divided by number of sample. Okay, that means probability of an event here will be equal to this one, number of events, divided by number of sample, this one. Okay, so now from there, this one will be the probability of an event. So I'm done for this question. Let me shift to another question. It will be question number 2 here. Okay, for this one now, it is said that 5% of each torch bulb manufactured by the certain factory were defected. What is the probability that when the bulb from that factory is tested will be defected? He says that 5% of the bulb, this one is defected. So what does it mean? If 5% of the bulb was defected, this means within 100 bulbs, 5 bulbs are defected. That is the meaning of saying 5% of the bulb were defected. That means within 100 bulbs, 5 bulbs are defected. In other language, I can say if my event is to find the defected bulb, now number of event will be equals to 5 because that is the number of the defected bulb, and also number of sample will be equals to 100. That is the total number of bulb. Okay, now from there, probability of an event is equal to number of event divided by number of sample. Now from there, probability of event will be equals to 5 divided by 100, and this one will be equal to 0.05. Okay, so now probability of an event is equal to 0.05. I'm done on it. Okay, now let us shift to the question number 3. The question number 3 says that a cone is tossed. What is the probability that head will occur first? A cone here is tossed. You need to find what is the probability that a head will occur first. As you know that a cone, it consists of only 2 sides. It is either head or tail. That's why my set of sample space, my possible outcome, will be head or tail. Only these 2. That means number of sample space will be equals to 2 because in my set of sample space I have only 2 elements here, head and the tail. Okay, but how about my event? Always event is obtained from the set of sample space, but my event is head, so we have to check at the sample space how many head are there. We have only one. That's why my set of event, it consists only head, because there is only one head here. Okay, from there I can find number of event will be equals to 1, because from my set of event there is only one element, which make number of event to be equals to 1. Okay, so now from there I'm supposed to proceed. I know that probability of an event is equal to number of event divided by number of sample. Then from there, probability of event will be equals to number of event 1, number of sample 2. Then probability of event will be equals to a half. Okay, let us shift. The question number 4. This question says that a piece of chalk is picked at random from a box containing 5 identical pieces, 2 of which are red and the 3 are white. You need to find the probability that the piece of chalk picked is red. So you need to find the probability that the piece of chalk picked is red. We know here there's a certain box, but inside the box there's 2 red and there is 3 white like this one. We need to find the probability of pick red chalk from this box. That means the sample spaces, which is a total possible outcome, will be 2 red and 3 white. That means set of sample spaces, which is a set of possible outcome, will be 2 red like this one, red, and also 3 white like this one, is a set of a possible outcome. Okay, what is a number of sample? Number of sample you have to count. How many samples do you have? 1, 2, 3, 4, 5. You have 5 elements from the set of sample space. So number of sample space here is equal to 5. Okay, what is your event? My event is to find the probability of getting red pieces of chalk. So my event here is red pieces of chalk. That's why set of event, it consists only 2 elements which are red. As you see here, there is only 2 red. That's why my set of event will consist only red and red, like this one. Then from there, I'll find number of event is equal to 2, because there is only 2 elements in a set of event. As you see here, this one is the first one and this one is the second one. Okay, let me proceed. I know that probability of an event is equal to number of events divided by number of sample. Then from there, number of events is equal to 2 over what is the number of sample? You have to find is equal to 5. Now write 5 here. Then from there, probability of an event will be equals to 2 over 5. I'm done for it. Okay, now we proceed. For this question now, we need to find probability that king appear in drawing a single card from the ordinary deck of 52 cards. So we need to find the probability of king to appear in a deck of 52 cards. Okay, this deck consists of 52 cards. That means the total number of cards is equal to 52 here. This one is the total number of cards. That's why I can say the number of sample space here is equal to 52, because I know the deck of cards consists of 52 cards. But also our event here is to pick a king. But from your experience, I think you understand that in the deck of cards there is 4 kings. So number of event here, which is a king, is equal to 4, because it's in that ordinary deck there is 4 kings. Okay, now we have number of sample and also we have number of event. Number of event equals to 4 because there is 4 kings in a deck of 52 card. Okay, now probability of one event equals to number of event divided by number of sample, which is equal to 4 divided by 52. So probability of one event here will be equals to 4 over 52, something like this one. If you want to simplify, you can simplify it. Also, you are allowed to do it. By simplification here, probability of an event will be equals to what? This one, 2 over 26, which is the same as 1 over 13. 1 over 13 by simplification. Okay, let me shift. Okay, so now you need to put on your mind that when you take the probability of an event to occur plus probability of an event not to occur, this one is equal to 1. You have to understand it. Okay, also, where is it coming from? This one is coming from this one. We know that the occurrence of an event, the occurrence of an event is presented by E. This means the certain event will occur, but for event not to occur, this one presented by E dash, as I said before, E complement. So this E complement means event not occur, and this one means event is occur. Okay, that's why in order to find the probability of an event, this one is equal to the number of events divided by number of sample. But this event, it depends either the occurrence of an event or the absence of an event. Okay, let me find the probability of occurrence of an event. This one will be equal to the number of events to occur divided by number of sample space. The same when I want to find the probability of events not to occur. This one will be equal to the number of events not to occur divided by number of sample. Okay, so we have two things here. This one, the first one for occurrence of an event, this one, and also we have this one for absence of an event. This one event occur, this one event not occur. So just to think, how come if you take the probability of certain event to occur plus probability of that event not to occur will be equal to what? Now check. If you take probability of event to occur plus probability of event not to occur, this one will be equal to, you have to define this one, probability of event to occur, which is equal to the number of event divided by number of sample, then plus. You have to define probability of event not to occur, which will be equals to number of events not to occur divided by number of sample. Okay, now it will be like this one. Just to proceed, you're supposed to take this one plus this one. Now from there we'll find equals to this one. Probability of event to occur plus probability of event not to occur. This one will be equals to, find LCM here, will be equals to number of sample divided by this one. We find number of event here plus number of event not to occur, like this one. Okay, but also you have to understand, always when you take the number of event to occur plus number of events not to occur, this one will be equals to number of sample. Okay, so now I can say the probability of event to occur plus probability of event not to occur, this one will be equal to number of sample divided by number of sample. Okay, this means probability of event to occur plus probability of event not to occur, this one will be equals to number of sample divided by number of sample will be equal to 1. That's why it says when you take the probability of event to occur plus probability not to occur, the answer must be equals to 1. So you have to claim this one, put it on your mind. When you take the probability of an event to occur plus probability of an event not to occur, always must be equals to 1. And if you shift this one to this side, you will find that probability of an event to occur must be equal to 1 minus probability of event not to occur. But also, if we shift this one to this side, you will find that probability of event not to occur equals to 1 minus probability of event to occur, something like this one. So the main formula is this one. You have to understand this formula. This one is a main formula. Make sure you understand it, because from this formula you will derive this one and you will derive this one. Okay, let me shift to the another part. Okay, now we have a question here. what is the probability of not getting a prime number when the fair die is tossed? Okay, when the fair die is tossed, the set of sample space will be an integers from 1 up to 6, because we know a die consists of integers from 1 up to 6. So from here, the set of sample space will be equals to 1, 2, 3, 4, 5, 6. This one will be the set of sample space. Okay, what is the number of sample space? Number of sample space, you have to count. This one will be equals to 6. Okay, so now from this question, we need to find the probability of not getting a prime number. So our event here is not getting a prime number. That's why your event will be set of all element which is not a prime number, because here we need to find the probability of not getting a prime number. So event will be all number which is not a prime number. Okay, here we will find this one is not a prime number, so 1, and also another one which is not a prime number. This one 4 is not a prime number. Another one which is not a prime number, this 6 is not a prime number. This one, something like this. Okay, so from this one I will find number of event. The number of event here, we're supposed to check the number of element in a set of event. How many elements we have? Here when you count, we have only 3 elements, which is 1, 2, 3. So we have 3 elements from there. So this one is a number of event, but this one is a number of a sample. I can find the probability of an event, which will be equals to number of event here divided by number of sample. Then this one will be equal to 3 divided by 6. From there, I can say probability of an event will be equal to 3 over 6. When you simplify this one, will be equal to a half. That's why probability of an event here is equal to a half. I'm done for that question. Okay, let us shift. The question number 7. For this question now, it is said that the probability of selecting red ball from a box containing red ball, green ball, and this one, what is the probability of not selecting a red ball? Okay, you have to understand the question, my friend. The probability of selecting a red ball from a box containing this one or this one. So this 1 over 4 is the probability of selecting a red ball. So now let me write it. Probability of selecting a red ball. So my event is selecting the red ball. That's why probability of my event, but what is my event is to select a red ball. This probability is equal to what? 1 over 4, as it said from the question. So this one is a probability of an event, but my event is to select a red ball. Okay, but also he said that what will be the probability of not selecting a red ball? We need to find what is the probability of not selecting a red ball. The probability of not selecting a red ball here, event complement, because it is not selecting a red ball. This one will be equal to this, equals to what? Okay, now you have to refer from the formula. When you take the probability of certain event to occur plus probability of certain event not to occur, this one must be equal to 1. So this one is the probability for red ball to occur, and this one is the probability of red ball not to occur. But this probability of red ball to occur is equal to 1 over 4. When you plus with the probability of that event not to occur, which is red ball, the answer must be equal to 1. So in order to get this probability, you're supposed to shift this one into that side. So have to shift this one to this side. Now from there, I'll find probability of an event not to occur will be equals to 1 minus 1 over 4. From there, I'll find probability of event not to occur. This one will be equal to 3 over 4. So I have done it. It is very, very, very simple. This one will be the probability of an event not to occur, probability of not selecting the red ball. Okay, now I'm proceeding. The question number 8. For this question, it says that when tossing a die, what is the probability of getting at least a number greater or equal to 1. When you're tossing a die, we need to find the probability of getting a number at least greater or equal to 1. Okay, I know that die consists an integers from 1 up to 6. That's why set of possible outcome is an integers from 1 up to 6, because any die consists these integers. So 1, 2, 3, 4, 5, 6. This one is a possible outcome. That's why I call it as a set of sample space. Okay, so what next from there? I am supposed to write the number of sample. How many sample I have? I'm supposed to count it. This one will be equal to 6 samples. Okay, how about my event? My event here is to find the number at least greater or equal to 1. So you have to find the number which is at least greater or equal to 1 from your set of sample space, because we know always event is obtained from the set of sample space. Okay, from this set of sample space, which numbers is greater or equal to 1? Here I will find equals to 1 is greater or equal to 1. Then another number here is 2 is greater or equal to 1. Then 3, 4, 5, up to this 6. Also it is greater or equal to 1. So this one is my event. Since this is my set of event, I can write the number of event. Number of event, this means the number of element in the given event. So number of event here will be equals to, let me count number of element here, 1, 2, 3, 4, 5, 6. Okay, so number of event here also is equal to 6. Okay, now I have number of event here, and also I have number of sample. Okay, let me find the probability of an event. Probability of an event equals to number of event divided by number of sample. From there, I will find this one will be equals to, my event is 6 divided by my sample is 6. Okay, so now probability of event will be equals to 1. Okay, therefore the probability of this event equals to 1. What does it mean? It means the event is complete, must occur, and this is correct. Even if you check to the question here, from this one, you need to find the probability of getting a number at least greater or equal to 1 from the die. Always die, it consists a number which is greater or equal to 1. So it is a compulsory to find this kind of numbers. That's why we find its probability is equal to 1. Okay, let us shift to the last one. Okay, this is exercise. Make sure you try yourself. In case there's any problem, concern with me via my WhatsApp number. I will help you. This will be the end of my presentation, but what I want to talk with you, my friend, make sure you struggle in studying mathematics. But on top of that, do not forget to subscribe on my YouTube channel in order to get more tutorial videos concerning with mathematics. My YouTube channel is what we call Some Form Online. Goodbye.